All right, for this one, we're going to tackle a truly mind-bending question. We're going to journey down to the very center of our planet, find the engine that makes, well, everything possible, and then we're going to shut it off.
Okay, so let's dive right in. Just imagine for a second that thousands of kilometers right under your feet, the very heart of our world, just stops. What would actually happen if this planetary engine, one that's been chugging along for billions of years, just went silent?
So to even begin to answer that, we've got to travel to the center of the Earth. Let's take a look inside the planet's engine room, to really understand what it is we're talking about turning off.
Okay, so the hero of our story, and I'm not kidding, it really is the hero, is this process called the geodynamo. Yeah, it sounds complicated, but you can just think of it like a natural planet-sized generator. It's this incredible, self-sustaining machine that creates one of the single most important things for life on Earth, our magnetic field. So how does this whole generator thing work? Well, it's kind of like a beautiful four-step dance. First up, you've got this immense heat bubbling up from the core. A lot of it is left over from when the planet first formed, plus it's fueled by radioactive decay. That heat gets everything moving. It makes the molten iron in the outer core churn and flow, creating these massive currents. Next, as the Earth spins, it adds this twist to the flow, kind of like steering a pot, but on a planetary scale. It twists that flowing iron into these huge corkscrewing columns. And that motion, all that sloshing conductive molten iron, well, that's what generates our powerful protective magnetic field. Simple, right? Okay, so now for the scary part. What happens if we just stop all that motion? This is where the very first, and maybe the most important, domino falls. That shield, the one that protects all of us, it starts to collapse.
And the consequences, they happen terrifyingly fast. Without the core's motion, the geodynamo just sputters out and dies. Now, the magnetic field, which stretches tens of thousands of kilometers out into space, it wouldn't vanish instantly, but on a geological timescale, it might as well. We're talking about it weakening dramatically in just a matter of months.
And if you look at the timeline for this decay, it's really startling. In just a few years, those beautiful auroras, the northern and southern lights, they just vanish from the sky. That's the first big visible sign that our shield is down. Then, within a few decades, our communication satellites would start failing, completely fried by all that unfiltered solar radiation. And in just a few centuries, the radiation on the surface would spike so high that large parts of the planet would become dangerously uninhabitable for complex life like us.
And believe it or not, that's just the beginning. Without its shield, the planet is totally exposed to the harshness of space, and that's when it really starts to, well, unravel.
The long-term threat is even scarier. The solar wind, which is this constant stream of charged particles blasting from the sun, it would basically start to strip mine our atmosphere. Over thousands and thousands of years, it would just rip away the lighter gases, thinning out the very air we breathe, and changing our climate forever. Our planet would start heading down a path that, well, it looks a lot like Mars. Yeah, the comparison between Earth and Mars it's pretty stark. See, Earth is this living, breathing world because we have an active core. That's what gives us our shield, our thick atmosphere, our dynamic geology, the whole shebang. Mars, on the other hand, is basically a fossil. Its core died billions of years ago, its shield went away, and the solar wind just scoured its atmosphere clean, leaving a frozen desert. That's the exact fate that would be waiting for us. And the damage doesn't stop with the atmosphere. That same heat from the core, it's also the engine driving plate tectonics. Without that heat, the slow churning motion of the mantle would just stop. The movement of the continents, the building of mountains, volcanic eruptions, the entire geological pulse of our planet, it would all just grind to a halt.
All right, let's fast forward, way, way forward into the deep future of this dying world. After all that initial chaos, what's left is just a long, final silence. We are now looking 100 million years into this really bleak future. It's an almost unimaginable amount of time. And over that vast stretch, the very last of the planet's internal heat would finally radiate away. The transformation into a fossil world would be complete.
At this point, the entire inside of the planet basically enters a permanent state of geological hibernation. The mantle would freeze solid, the last volcanoes would flicker out, our planet would just become a quiet, solid ball of rock and iron.
So here's the final family portrait of our fossil world. You've got oceans frozen solid, an atmosphere that's just a thin veil, continents that are totally fixed, never moving again. The carbon cycle, which is so critical for regulating temperature, it would have just stopped completely. Earth would be a silent relic in space. Maybe, just maybe, some tough microbial life could hang on deep underground, but that's about it.
Okay, wow, that was bleak. So after taking that pretty horrifying journey, I think it's time for a very important reality check. Let's pull back from the thought experiment for a second and ask the one question that's probably on your mind.
Could this actually happen? I mean, could the Earth's core just stop?
Well, the answer, thankfully, is all about what powers that engine in the first place. So, yeah, some of the heat is left over from when Earth was formed, but the vast majority of it, we're talking like 80%, it comes from the slow decay of radioactive stuff like uranium and thorium that's mixed into the planet's guts. And here is the really, really good news. That radioactive fuel, its half-life is measured in billions of years. So, scientifically speaking, the chances of the core just stopping anytime soon are, well, they're basically zero. The engine has more than enough fuel to keep running for at least another billion years, probably a lot longer. So you can relax. Our planet is not dying anytime soon.
So you might be asking, what's the point of all this? Why even imagine such a terrible end for our world? Well, it's really about understanding what makes our planet alive in the first place.
Because when you get right down to it, the true heartbeat of the Earth isn't its daily spin or its trip around the sun. It's this deep, invisible, and constant motion happening right under our feet. That flow of molten metal, thousands of kilometers down, is the rhythm that drives the continents, that holds onto our atmosphere, and ultimately protects every single living thing on the surface.
And that right there is why this thought experiment is so powerful. You see, if our worlds were to end like this, it wouldn't be some big, fiery explosion. It would be a slow, quiet fade into a cold, geological silence. And it's an incredible reminder of the powerful, hidden forces that make our amazing, vibrant, noisy, living world possible in the first place.